All right, so I want to talk about arrays this week. An array is a kind of a special type of data. I've actually do have some recordings on these. I've recorded them. I've not had a chance to edit them yet. I will be working on those when I get done with my classes today. Excuse me, but an array is a special data structure inside of C++. We've seen something similar. If you go back, you remember what we were talking about with the old Python class. Our Python class, if you remember correctly, we had list, and I provide a link for that just so you can kind of refresh yourself if you need to. And so it's similar, but a little bit different. A list is a lot more generic in what it can do, because it can store any type of data, and it has several functions that are built into being a list. So if you're a list, you automatically get these functions built in for you. With an array, it's very, very simple. All your elements of an array have to be of the same data type. We kind of saw in Python that really didn't matter. You know, Python data types were Python data types. You just kind of did whatever. Whereas in C++, that's obviously a little bit more restricted. The other thing, this is just kind of a way that they work behind the scenes, and I listed there on the piece. I said that your data has to be a contiguous space of memory. And what that means is, if I can stop that share and share the whiteboard. This is actually kind of an important thing to understand. If I've got like an integer, I've got a little box of memory that's out here, and this is going to store a number. Let's say it's going to store the number 8. I think I did a great job drawing an 8 there. I'm not going to do any more. I'm going to call that success. Okay, so I got an 8, and that little box of memory, it's got a memory address that it knows about. And if you were to look at that, you might have an address that says something like 0x, and then that lets you know it's a hexadecimal memory address, and then it's got something, you know, 1, 2, 3, ABC. And that's your memory address, okay? Nothing real fancy, but that's how the computer knows it. You know this as, you know, something like, you know, meals eaten this week so far, or running total, or, you know, anything that you might have as far as a variable name. But the computer knows this as a memory address. When we work with an array, we take the same basic idea. Let's draw. Oops. Let's see what it is. Why is this not working for me? I was going too fast. Okay, so I'm going to have as an array have to kind of draw slow. I'm going to have my first element, and then I'm going to have a second element, third, fourth, etc., etc. And I'm just going to put a couple of ellipses here. This could be, I could have 500 of these, okay? Doesn't matter. The key thing is I have to be contiguously found in memory. Now, as I get more and more elements in my memory, and my computer becomes more and more full memory-wise, this becomes harder and harder to do. So this is why C++ says that you have to have a contiguous piece, and you have to create it all at once, because trying to go in and find an extra space later on is really hard. And what the computer does is very similar to how you you accessed it before. You've got your memory address. So here's 0x123 ABC, and we're happy as far as that goes. And then we reference each of those boxes by an offset. So it says, oh, I know I'm an integer, and integers are 4 bytes. So I'm going to say 123 ABC plus 0. And this is going to let me come in here and reference element 1, which is 15, let's say. And then it says, well, I want to reference the second box. Well, the second box is going to be 123 ABC. I'm an integer. I know I'm 4 bytes, so plus 4 bytes. And so it uses this index as an offset. And in here, this is 23. And then if I go to the fifth one, so I go 0, 1, 2, 3, 4, 5. Okay. Now over here, I'm 42. And I can keep going and reference any element I want. Now, I might only have this many, 7 elements in here, 6, 7 elements. I could say, hey, I want to access element 10. And this is where an array in C++ gets really kind of dangerous if you're not careful. You can hurt yourself, is because it's going to say, oh, okay, here's 1, 2, 3, ABC, okay? Go to index 10, 4 bytes apiece, add 40 bytes to this. And it's going to do the hexadecimal math, and it's going to figure out, okay, I'm going to reference this element over here. The problem is this element way over here that I've got a section out here in memory that I can find the address for, but it's not part of my array. So it's part of some other variable possibly, and I just stepped all over it. And what is that piece of memory doing? I don't know. Is it another application? Is it just another variable that we're using someplace else? That now, my string's not going to make sense because I put a 56 in the middle of it. That it has to convert into, ANSI code. I don't know. And so we can get ourselves in some trouble if we're not careful. So I'm going to show you some things that we can do to make our lives a little bit easier with working with this. But we just have to kind of keep this stuff in mind. And I don't want to say this to scare you. I just want you to keep it in the back of your mind, because if you keep it in the back of your mind, then you don't make these mistakes more than a couple times. Everyone makes them a couple times. That's okay. But after just doing a little bit, you don't make these mistakes anymore, and life becomes a lot easier if you just keep these things in mind. All right, so let's talk about first how we're going to define it. And there's a couple different ways that you can do it. You always define with your data type, your array name, which is basically just a variable name, and any legal variable name you can use for an array. Now, this is a personal thing. You'll see whenever I'm making arrays, I use a plural name. So instead of saying score, I'll say scores. Instead of saying temperature, it's temperatures. And that's just a little hint to myself to remember I'm dealing with an array. I'm dealing with more than one element. So that is not required by any stretch of imagination. That's just one of those little tricks that I picked up over the years to help me keep stuff organized. Then I specify the size of an array. Excuse me. So I have to specify that size at the beginning. I can't add to something later on. So that's a big frustration if you come out of some other languages that you might have had experience with, like JavaScript or Python, something like that. We got 10 minutes left of this meeting. If this meeting ends, we will try to log back in and see if we can restart it. Okay? So just FYI.
Are there time limits?
There are. It's 40 minutes. So if the meeting ends, we'll just try to log back into it. I think that buys us another 40 minutes. If it doesn't, I will create a new meeting and send that out. So we will make this work, don't worry. All right, so, excuse me. Here's an example down below, double quiz scores, and I specify 5. Now, because this is something that gets used a lot of different places, I like to use a constant, and I'll make a global constant just to make it so I can reference it other places, because I need to know that limitation. Because I can't say, oh, what's the size of my array? But I can if I define a constant to hold that limitation, that size. Because, and the reason why is a lot of times we use like a for loop to iterate through an array, and so knowing how big my array is becomes really, really helpful, and that's a perfect example of that. Okay, to access an array, you can do something like this. So here I have like int class size, and I specify, okay, here's 5 elements that I'm going to have, and then I do elements 0 through 4. That's all 5 elements. Remember, you always start at element 0. C++ is a zero-based array system. And if I need to read something out, I just, like I normally would, I just specify my index. So if we look at this real quick, I'm just going to copy this into, oops. Okay, so here I've defined my array name, my index of how big it's going to be, specified values, and then I can specify an actual element. All right, so my mouse is doing its own special thing today. So if I look, I went in and got element 3. So 0 is 1, 1 is 2, 2 is therefore 3, which is 11, which is what that one shows, which is exactly what we're kind of hoping for lack of a better term. Now, what would happen if I didn't put an index? I just said, hey, class size. So if I do that and then run, notice what you get. Okay. Remember I talked about that hexadecimal memory address? Well, that's what I got. It says, oh, here's a place of memory. And so it says this is the memory address of index 0. Not real helpful to us. That's why we always have to specify that index. It's legitimate code. It worked. It's just not doing what we wanted it to do. We can do some tricks with this in C++, with how we access and handle memory. That's not what we want to do. We just want to use those indexes because that's a lot more simple for us.
Would there be a time where it would be useful to just get the memory code?
There is a couple, and in the old days when you were doing, especially C programming, not so much in C++ is not as encouraged, but in some of the old C programs, you could do what they call pointer math and do this for, basically replicate the idea of the concept of your indexes, but you could do some jumping in space to find memory locations. You're kind of replicating what doing the index does for you, so it's not real important with arrays, in my opinion. But you can, and that was actually a way that they used to do it in days gone past. But we don't have to do that anymore. So I don't want to encourage unnecessary work, for lack of a better term. That's just being unnecessarily difficult, I think. Here I have an external constant. So here where I put in 5, I could have put in my constant value. Obviously, it works the exact same way since they're both an integer, and that's the important thing as far as that goes. So I can assign values just as easy as I can read them. I can read and assign values, and that's all good. Another thing that I can do, which is kind of interesting, and I'll show this to you before we end. Let's see if I can copy this. Aha. Okay, so here I had just a series of temperatures. I think this is the temperatures like last week or something like that. So I can remember if I just say int class size 5, I define a variable, but there's no values in those numbers. I can actually declare an array and assign it a value at the same time. And here's how that would be done. I can also, if I'm declaring my values, there's a couple things that are kind of tricky you need to know about. Number one is I can have fewer elements than I specify in my index. So if I have an index of 15 and I specify 5 elements, that's okay, that works. But if I specify 3 and I have 5, notice it gives me that error right away. Too many initializer values. Okay, so I can have more elements defined than declared, and that's okay. I can have the same number of elements defined and declared. That's okay. I can declare elements and not define a number, and it will calculate how many indexes I need and create an array of that size. So those are all things that it does for me, but I just have to make sure I don't define a smaller number than I declare.